Well, hello everyone. Today we are going to start with a new unit. It's Unit 7, and Unit 7 is all about strings. Now, I just want to remind you about something previously, and we saw that a lot. Every time you want to compare between two strings and you use the double equal sign, I told you, like, this is not the right way to do it. Well, today we're going to learn why we're not supposed to do it that way. And there's a good explanation about that, and Java basically did it in a different way. So you really need to pay attention to try to understand how Java treats strings. So today we're going to talk about characters functions, strings, string functions, and another topic which is very, very important. It's what we call the string builder class and the string buffer class. Both of them are very, very similar. There's a few differences between them. As a programmer, you will not be able to tell the difference. Like whatever you can do with a string builder, you can do with a string buffer. It comes with the performance versus stability, the stability of your code. One time you have to go with string builders, one times you have to go with the string buffers. We're going to talk about that later. But for now, let's just start about how I'm going to run this unit. Basically, I'm going to go through those PowerPoint files, and I'm having Eclipse open here, and I'm going to go through Eclipse to demonstrate what do we have. So those are the objectives for this class of today, and the first thing we have to understand is a string by itself, it's not a primitive data type. And I said that before. I'm going to explain what is the meaning of primitive data type. Well, an integer is primitive data type. Boolean variables, primitive data type, doubles, floats, characters. All of those are primitive data types. And primitive data types basically means they're part of the programming language. A string, even though characters, by the way, is a primitive data type, but a string, again, it's a very, very important type of data, but yet it's not a primitive data type. And that basically means someone created the strings after they created Java, not as they are creating Java, they created strings. No, after they were done with creating Java and Java as a programming language, it's completed. Someone else came and created a class they called a string, and because it's very, very important, so it's part of the standard library. And what is a string, by the way? A string is basically a group of characters. That's it. And again, when you put group of characters, you create words. When you put words together, you create sentences. And this is how we communicate. And this is not how computers communicate. But again, in a lot of cases, we need to communicate with the computer. So the computer needs to learn to speak our language, just like we are trying to understand his language right now. So that's basically what is a string. So how do I make the computer process strings and deal with strings? That's a big deal, and it's usually a whole chapter in every single programming language, and it's kind of a very big deal in Java specifically. So as a bottom line here from this slide is basically strings is not primitive data type, and that basically means whatever you have in ideas for for integers and doubles and characters will not be properly applied to a string data types, and we're going to see how do we apply operations on strings. As you can see here, this is what I was talking about. When you have two strings, you are not allowed to compare them using the double equal sign. And again, there's an explanation about that, and we're going to talk about that later. So basically, we cannot compare those values. I am going to skip this explanation till I get to the PowerPoint slide where it will make more sense, and I'm going to go and demonstrate it on the Eclipse as well. But again, let's just put a bottom line here. When you have a string and a string, and you want to compare and see if those two strings actually have the same values, you are not allowed to use a double equal sign. Put that in your head. How do I do that? We have other tools, and we're going to talk about that later. So this is just an example to tell you that using, see, you got two strings here. The first one's called name, and the other one's called other name. The first name is assigned, Cameron was assigned to the first name, and the second name you were asked to enter Cameron, for example, or enter any other value. When you try to compare those two values together using the double equal, you're not comparing the values, you're comparing something else. Again, I need a graphic to explain what am I comparing exactly, and that's basically what we're going to be talking about in a sec. Okay, so those are the topics we're going to talk about today: a character, a string, and a string buffer and a string builder. And again, as I said, by the end of this chapter, we're going to learn what's the difference between a string builder and a string buffer. But for now, this is a single character. This is a group of characters that are going to generate what we call strings. And this here is what we call a string buffer or string builder, which is, again, they basically came to solve one specific problem that strings has. And we're going to talk about that in a sec. Okay, so let's start with the characters. How do I create a character? Well, we did that before, and I hope you guys remember that. To create a character, just use the keyword char, and let's say I'll put A, that's the name of that character, and you have to remember you put single quotations and you put T, for example, uppercase T, or any character for that matter. I can put, for example, this character. I can put Arabic character if I will. Let's see here. Do I have Arabic? Yeah, here it is. You can put any character in the world, any language, and it will be stored with no problems. So that's a character. What do you mean by character methods? Well, in a lot of cases, when you process characters, or sometimes when you process the characters of the strings themselves, you want to do some tests on those characters. For example, you have a character, let's put, for example, here F. Now I want to see if this is a lowercase f or it's uppercase f. I can check. And then if it's a lowercase f, how do I convert it to uppercase f? Well, there's a method for all of that. And Java made it a lot easier comparing to other programming languages. You can get that done using those methods, or you can actually do it yourself by treating the characters as an integer and find the difference between the uppercase decimal value and the lowercase decimal value and just adding or subtracting depending on what you're trying to do. And then you can do the conversion. But again, lucky for us, we are not going to try to do that. We're just going to learn how to use those methods. So basically, I do have this character that I created, which is an F. And now, characters mainly are categorized into two, character methods, sorry, are categorized into two main methods. One of them is the to, and the other one is. Is basically, usually those methods start with the two letters, the I and S, and this is where you're trying to check a character. For example, here I'm checking if a character is in uppercase, and usually those methods return a Boolean variable because, again, it could be true, it could be false. Now this here will convert it to an uppercase or a lowercase. It depends on what you're looking for. You can convert to uppercase, you can convert to lowercase. So usually what we do, we check the character first, and then after that we decide do we have to convert it or not. For example, if I want all of my characters to be uppercases, well, if it's an uppercase, then just leave it. So I have to check if it's a lowercase first, and then after that I convert it to uppercase if it's not. So we do have a long list of methods, and I'm going to go through this list and explain them one by one, and then we'll demonstrate them. First of all, is uppercase. As you can see here, you're checking if it's uppercase. To uppercase, this is where if it's a lowercase, if this function basically return a false, that basically means it's a lowercase, then you have to convert it to an uppercase. And the same thing for lowercase to lowercase. Oh, I can check if it's a digit. That's very important. Sometimes when you ask the user to enter some values, numbers, what if he entered, and he treated it as a character? What if he entered a character instead of a digit? For example, how many fingers do you have? He will say Z. Well, Z is not acceptable. You need to have a number between, well, we have 9, 10 fingers, so that's not going to be enough for a character. But again, let's say how many fingers you have in one hand. Let's just put it that way. So you got 5. So this is a digit. You check if the number that the user entered as a character is a digit or it's not digit. You can check if it's a letter. And sometimes you can check if it's a letter or a digit. I accept letters as digit, but I don't want special characters like the space or at or the asterisk or parentheses. I don't want them. I want to check if it's just letters or digits. And then I can check if it's a white space. So all of that could be checked, and some of the function could be converted. Now, the very, very important thing that whenever you want to use any of those methods, and this is very important, you basically have to put the keyword character, and the character here is basically represent a class. And then dot is upper. So this is the class. Is upper is what we call a static method. And then inside, between the parentheses, you put your character that you're trying to check. So let's go ahead and do that. And we use it with this example here. So I'm just going to go ahead and apply that. So system.out.println. And I'm going to choose them all. Character dot, well, it looks like, let me see, oh, of course, I remember, is uppercase. And then I'll put A. Oh, I really hate my Java compiler here. Let's just run it. And remember, I have a lowercase f, and I'm asking, is it an uppercase or not? So if I just run it, it's supposed to be false. And here we go. You got a false. Now let me check if it's a lower. Let me just copy that. And by the way, I'm going to post this code later, so it will be very helpful for you to look at the code later after you're done watching the video. So what if I put here lower case? You would notice that, yes, since it's not an uppercase, then it's a lowercase. Okay, what else? Let me try to convert it. A equal character dot to upper, sorry. I'm trying to convert it to an uppercase. And I'll put A here. And let's try to print it on screen. And all I want to do is just to print A. You will notice that A will not be a lowercase anymore. It's going to be uppercase. Now let me check and see if it's a digit. Okay, let's see if it's a letter. Okay, it's uppercase L. Again, this is what I hated. It doesn't show you suggestions. Is it, let me see, which one of this is a digit or uppercase? How do I combine between them? Is it letter or digit? Yes. This should be true because, again, it is letter. And let's see if it's a white space. And that should be false. Okay, why you don't like it? Let's see here. White. Oh, space lower cases. How come? Okay, so let's go one by one and see the results. Now, remember, I'm going to highlight the results and then go and check the sentence. Okay, let's go all the way up so we can see everything here. So, first of all, I'm checking if it's an uppercase. No, it's not an uppercase. Then I'm checking if it's a lowercase. Then yes, it is a lowercase. And then I asked them to convert it to an uppercase, so I got F. And then I checked if it's a digit. Then I got false. And then I checked if it's a letter. Then I got true. Then I checked if it's a letter or digit. So I get true because F is a digit. And sorry, letter. And then after that, I checked if it's a white space and it's false. Those functions, again, are basically everything we need to know about characters. We've talked about characters before, but now those are some tools that will be available for you if you want to convert your digits, so your characters from uppercase to lowercase, or if you want to, what else? Check if it's a letter, or check if it's a digital or white space, or lowercase or uppercase. Okay, so I am going to stop at this point because this will be the end of the character section. Now, we also know how do we read a character. We just basically use your scanner object .next. Okay, so let's go ahead and see what else do we have. Okay, those are just testing, just like we did. Okay, now we're going to talk about strings. And this topic is one of the topics that I think in interviews they pay attention to it, because strings are a very special type of characters. Now, one thing you should know about strings. Strings are immutable variables. What does immutable variable mean? Let me just make sure that I'm using the right term here. I'm not making... Yep. As I said, strings are immutable variables. Okay, now that term, you should stop at it. What is the meaning of immutable variable? Immutable variables in Java means once the variable is created, you cannot change its value. Now, your head now is going to jump into what? You're going to ask me that question, or you're going to ask yourself that question right now. You're going to say, okay, if a string is immutable, then what is a final variable or constant variable? Well, that's a totally different story. And I'm going to explain the difference between them right now. But we should understand something, and I wish I do have a mouse here. My son took my mouse. Anyway, immutable variables basically means, and you need to pay attention to this, is just close your eyes and try to imagine what am I saying here. When you create a string in your program, what's going to happen? Your program is going to issue an order to the operating system to reserve a space inside the memory to store that string. For example, I create a string, I call it Ali. Now, there's a space inside the memory. Now, I'm just giving you the basic explanation, then I'm going to give you a little bit more details. So there's a space inside the memory reserved to store that name, Ali. Now, and let me just do that. Why do I have to explain it like that? Let me just come here and do that. How do I create a strings usually? Well, there's multiple ways. I'm just going to show you the traditional way. Name, and let's put Ali. Now remember here, strings start with uppercase S, and you use double quotations. Now there's another way to do that. Let's just call this name 1. And again, just remember, this is equivalent to this. Of course, I didn't make any change, so let's just come here and say new string. So those are very, very similar ways to create strings. The way we usually go with this one, the first one, because it's a little bit shorter, easier to do compared to adding those words. But again, this basically tells you that name is not a primitive data type. It's basically an object, and the reason why I think it's an object is because we use the keyword new. And this is me calling the constructor and passing Adam as an argument. Okay, so let's go ahead here. String name 1 equal Ali, string name 2 equal Adam. So what's going on here? After you compile or execute those 2 lines of code, your computer basically is going to reserve spaces inside the memory to store the word Ali and to store the word Adam. That space inside the memory has an address. So there's a memory location, or actually locations, to store Ali, and there's a group of memory locations to store Adam, 2 separated memory locations inside your computer system. Each one of them, and remember this very clearly, each one of them has a unique address. Now, look at this. If I say if name1 double equal name2, well, something's going to happen. Let's just put, let me see if I still have it here. Open up my URL. Let's put it here. I'm just going to put test, just to show you what do I mean by this. So, now, I want you to look here and tell me. When I'm using name1 equal name2, using the equal sign, I am not actually comparing the word Ali with the word Adam. I'm not doing that. What am I doing here? I'm telling the compiler, does name1 and name2 are referencing the same memory location inside the memory or not? And basically, that's not the case, because again, we said there was a space reserved for Ali and there's a space reserved for Adam, so both of them are not pointing to the same memory location. Each one of them is pointing to a different memory location. The one that is pointing to Ali, and there's another one that's pointing to Adam, so basically, that's not true. And look at this. This is basically correct. Even if you decide to ignore this fact, yeah, Ali doesn't equal Adam, but again, that's not how it works. This is basically when they ask about those questions in interviews, they want to know how how much deep is your level of understanding what's going on in Java. So this is very important to understand. Now, when you use double equal assignment with, I just need to make sure my wife, she has an interview and a meeting in the computer. So I need to leave the computer in 30 minutes or something. Okay, so let's go back here. I'm comparing name1 with name2, not name1 and name as variables. I'm comparing the address of name1 with the address of name2, which basically in this case is going to be false. So I'm not going to see the test. Let me just come here and type another message. Let's put by. So we'll see that by will be printed. And let me just comment the first section here. So I don't want to see that anymore. Okay, so let's go ahead and do this. And you'll see that I was just a byte because, again, both of them are not pointing to the same memory location. Now, this is the tricky part. Whatever I said is not tricky. But here's what's the tricky part. What if I came here and say name2 equal Ali? So what did I just did here? I changed the value of name2 from Adam to Ali. Now, before I run the code, let me explain what's going to happen here. Strings, as I said, are immutable. And immutable basically means you cannot change the values, but I just did it. Here it is. Name2 was Adam, and I changed it to Ali. So what happened inside the compiler? Well, here's what's going to happen. Immediately after your compiler get to this point, name2 equal Ali with an uppercase A. Well, first thing I'm going to do, I'm going to ditch the memory location that contain Adam. That is going to be called garbage memory. Number one. So there will be a space inside the memory with an address, and that address basically is pointing or holding, is for a memory location, and that inside that memory location we have Adam. After this line here executed, the compiler and the operating system will ditch that memory location and leave it, and it's going to be called garbage. So there's a memory location that holds the value Adam. It's going to be called garbage. Right after that, the compiler is going to look inside all the data you have inside your memory, for your program. Is there any other variables that is called Ali? And the compiler will find, yes, there is one that's called Ali. So the compiler will say, here's a smart thing to do. Instead of me having name1 with a memory location called Ali and a name2 with another memory location called Ali, why don't we just use both of them to point to the same memory location? What is the point of duplicating memory locations with the same value? And then, look at this. When I'm going to come here and compare those, I'm going to see the test, which basically means true. Now remember, this is very, very important at this point. When I'm comparing name1 with name2 here, I'm comparing the memory location of name1 with the memory location of name2. And that basically happened that whenever when I tried to assign Ali to name2, and the compiler realized that there is another memory location that's named name1 that has the same value. So instead of having a new memory location with Ali and making two memory locations that hold the same value, which basically represent a redundant data. So the compiler will do something smart, and this is part of memory management because that's basically the feature. That's the whole point of what we're doing here. And instead of duplicating data, no, make them all point to the same memory location that share the same value. So when I'm going to come to this if statement here and compare name1 with name2, I'm not comparing Ali with Ali itself. I'm comparing, and I'm asking, is name1 and name2 pointing to the same memory location or not? And that's the case here. So I'm going to get true. And now if I run it, I will get test by. Now, if you want to ignore all of what I just said here, basically you will get the same results. If the two values are the same, you'll get true. If they're different, you get false. But again, you need to understand that this is not how Java is doing it. Java basically is comparing addresses. This is to compare address, not to compare values. Even though if two addresses matches, that basically means both of those addresses are pointing to the same variable. So basically, you don't have two alleles that you're comparing to. You basically have two addresses that you're comparing to, and you're not comparing this address equals this address. No. You're comparing, is this address pointing to the same memory location, this address pointing to the same memory location. Or the name1 basically is holding an address, and name2 holding an address, and each one of those addresses basically pointing to the same address inside the memory, having the same address. So that's, again, the very, very special point about why we should not use double equal when we compare strings. Now, let's go back here. If Java is so smart and trying to save spaces, what's going to happen to the garbage? I told you, like, once you change the value of name2, the previous value is going to be treated as garbage and it's going to be inside the memory. Well, guess what? There is a software inside your Java project. It's called the garbage collector. The job of the garbage collector basically is to clean the garbage and take them out of the memory so you can use that space later on. Okay, so this is basically how we compare strings. Just remember this, it's very important. Strings are mutable, and basically mutable basically means you cannot change the value. Well, as I said, I just tried it and it worked. Well, basically, by changing the value, what are you doing? Your operating system is going to ditch this space reserved for this memory location, for this variable Adam, and it's going to be treated as trash, garbage, and then a new variable is going to be created with the same name, name2, and you're going to store this new value. And then when you compare them, you're just comparing the addresses. Is the address for name2 and address for name1 are the same? Basically, you're asking, are they two variables are pointing to the same memory location? If that's the case, then return true or false. Well, now with that being said, I'm going to tell you, if I see you compare two strings using double equal sign, I probably will take 50% of your grade. So what is the right way to do that? Well, there is a right way. Well, you know what? Let me just put it back here so you'll remember this. Control C, Control V. And by the way, this is very important. Later we're going to get back to this again. You put the first variable you want to compare with the second one, dot equal, and then you put name2. I think I misspelled equal. It should be, no, let me just make sure here. Name1 dot equal, and there's equal, ignore the case. Not you. So here we go, this is it. How do I compare it? Equal, okay, show me an example. What did I make a mistake with? Equals, sorry, not equal. I knew that there was a character here, equals, and it's gone. So, the difference between this and this will compare the IP addresses, why do I keep thinking about networking all the time? This will compare the addresses of those variables, and if they're the same, it's going to be true. This will compare the values of those two variables, and if it's true, it's going to be, if they're the same, they're going to be true. Now, let me just show you one last thing. If I come here, and let me just comment this section, I'll take it out, but there's something to think about. If I come here and change this to be Adam, what's going to happen here? Well, let me tell you. Basically, when you finish creating string name1 Adam, and then when you move to creating a string name2, the compiler will say, wait a minute, just hold on. I already have a space inside the memory that holds the value of Adam. Again, why would I want to create another space holding the same value? I will just make name2 point to the same memory location that name1 is pointing. So that basically means, again, two variables, both of them equal Adam. They share the same address, and this here basically testing for that. This here is testing for if they are same variables. Now you may ask this question, well, if they're going to be pointing to the same variable, isn't that basically means they're going to be having the same values? Yes, that's basically what it is. But again, the tool that you're using tells me what your brain is thinking, even though both of them are going to give me the same results. I just wanted to mention that and make it very clear. So let's go back here and put this back to be Ali. And by the way, I'm almost done, so with the string part, of course. So let's put that here, and let's take the comment section so we can move on to string methods. Just like character methods, we have a group of methods for strings. And before I go there, let's go back to the PowerPoint and make sure that we didn't miss anything here. So this is a string, literal string. Basically, whenever you use a double quotation, you put your strings and you just show it on the screen, like the hello world example that we talked about before. The class strings comes automatically loaded into your project whenever you create a project. So you don't have to worry about importing any classes here. This is just to show you that you have two different ways to create strings. Basically, they are exactly the same. The keyword new here, as I said, will tell you that this is an object, not a primitive data type. And as I said, each string is a class, string variable names, just like the rules that we have with other variable names. I just hold the string literal. Okay, this here is just to show you an example of what I was saying here. I created creating hello, and this is a string creating hello, and then after that I changed the value to bonjour. Oh yeah, that's a French word. I was like, what is bonjour? Anyway, so here we go. After you created the string, a greeting, hello, you basically are having a variable that's having an address of that hello variable inside the memory. Right after you change the value, again, it's immutable. We're not supposed to change the value, but again, we can. Right after you change the value, the first hello here, that's trash, garbage. You cannot use it anymore. Your greeting is now holding the value of bonjour, and the bonjour, to be specific, has a new address, and after that the garbage collector is going to come and clean the memory from that hello world. I hope that is not complicated. Again, this is what I was talking about. Here we go, equals or equal, ignore the case. Now, equals when it's a case sensitive, equal ignores the case when it's not a case sensitive. Get prepared to use those methods a lot. Remember this. I don't know how many times I have to say this, but again, I will be really, really angry if I see someone comparing two strings using the double equal sign. I did it before because we didn't get to this chapter yet. Now we're here, we need to go with equals or equals, ignore the case whenever you compare between two strings. What else? Now we can talk about more methods that comes with the string family. We talked about equal, ignore the case, and now we're talking about compare to. Compare to, basically you compare two strings. Now, how do I compare two strings? Well, here's how it works. If I have two characters, let me just go ahead and show you that with an example. I'm going to come here and create a string, str1 equal, and I'll just put ABC. And then I'm going to create another string, str2, and I'll put ABC. Well, first of all, since they're exactly the same, so we know that they're both pointing to the same family. So system, well, let me see here if I can, no, Control V, oops, yeah, I knew it. Let me copy this. So let's go over here. Now I don't want to see the by, I want to see, well, what is it? compare to? Is it uppercase? No, yeah, of course. So I will just put str1 dot compare compare 2 str2. So what's going to happen? Let me just explain what's going to happen here. It's going to compare character A with character A, character B with character B, character C with character C. If they match all the way to the end, then basically it's going to return 0. Let me run it, and you'll see a 0. Please. Yep, here it is. Put a 0. Now, let me change that. What if I change this to be a B? Well, you know what? Let me just change this way. Let's keep it A. Keep this one B. And what do we have? We have D after C. So what's going to happen here is going to compare A with A, B with B, match, match. And then compare D with C when now D in the alphabetic order comes after C. So every single character has a decimal value. So it's going to subtract the decimal values from each other. So C is going to be subtracted from D, and since the difference between them is one character, so I'm going to get positive 1. Okay, what if I flip it? Put C here and put D here. Well, can you guess? I'm going to click negative 1. Now, I'm going to put the C back again. I'm going to put F. Now, can you guess what's the difference between them? C is going to be subtracted from F. So what do we have? We have D, E, F. So the difference between them is going to be 3. And if I replace this C and put F here, I'll get a negative 3. Now, of course, if I put the difference here, for example, maybe C, let's put C here, so B and C, so that's supposed to be negative 2. Once there's a difference between characters that's compared to, there's no need to keep going. So basically, A and C are done the same, that's it, that will be it. Give me a negative 2 and stop. Even if I come here and change this to be, for example, T, it doesn't matter. Negative 2. The first time two characters do not match is going to tell you what's the difference between them. That's the compare to function. So I can compare strings with strings, and instead of returning true if they match or false if they don't match, I can return a number, and that number somehow tells me some information about the alphabetic order of those characters that build both of those strings. But again, it's a method that's available. I don't know if you want to use it or not, or do you have to use it or not. We'll see later. Okay, so any minute my wife's going to come. So I need to, maybe I'll make this in 2 videos just in case. Empty strings, again, you can put a string with the null keyword, or you can put double quotations with no characters. 2 upper, 2 lower O. Look at this. This is very important. Yes, I think I do have like 20 minutes. I should be able to get this done. I'm going to stop whenever I get to the string builder and string buffer, and then after that we'll continue with another video. So basically this chapter will have 3 videos. I'm going to try to answer questions in the 3rd video. So we got those functions here. 2 upper, 2 lower. The length basically will return how many characters I have. Index off, you basically you put a character there, and you ask me where's that character located in this string. If it's going to return negative 1, that basically means it doesn't exist in that character. I'm going to give them a try. Let me just see what else. Character at ends with or start with. So those are the functions. Replace, toString, and okay, substring. We do have a lot. Variable, integer classes, double. Let's go step by step. I don't want to rush into anything. 2 uppercase. Well, let's try that. I'm going to change. Oh, by the way, I forgot to mention that this is a case sensitive. So when you compare it this way, it's not going to tell you this is the same. So let's try to convert those strings. So I'm going to say str1.to uppercase. And I don't think, yep, it looks like it's going to work. Let me just try to run it. Well, I don't think it's going to work. Let me just give it a try. Something doesn't look right. I think it's not going to work. Oh, should work. Sorry. No, it didn't. Let's see. What am I missing here? Do I say, you know what? I think I know what it is. Let me cut this from here and put it here. Let me run it again. And ABC. See, I converted. But again, the original value didn't get affected. It's just going to be printed as uppercases here, but the original value for string 1 is not affected. And by the way, do you see this 32? This 32 should tell you something. This basically means the difference between uppercase and lowercase is 32. And uppercase, lowercase has the highest value, decimal value. So let's just do the other function here. Control C, Control V, and let's convert SG2 to lowercase. And you'll notice that it will be converted to a lowercase. Now, what was the third function? The third function, length. How many variables, or how many characters, sorry, do I have inside each one of those? Now, this is very important later. Length. Well, did I make a mistake? LENGHTH returns the length of the string. Well, let's try to run it. Maybe it will tell me something. Our result method length is undefined for a string. No, it should be defined. Let me try to remember. Why is it acting that way? str1 dot length. Oh, here it is. Now it's gone. Did I make a mistake with a typo or something? Oh yeah, here it is. I don't know. Yeah, LENGHT. I didn't make any mistakes. Okay, let's keep going. If you notice any mistake, tell me. Index off. Let's go ahead and type str index off og, and I'll put a character here. We'll put B, for example. So B is located at, I'll remember, oh, this is very important. This is the B that I'm talking about. An index basically means the location of that variable, the position of that variable, the string. And you may think this is 2, but in reality, no, it's actually 1. We start counting from 0. Remember, this is a fact that you have to remember. So A has a location of 0, B has a location of 1, and C has a location of 2. Let's run it. And here it is. B is 1. And the third method, which is character at. Well, if you want to do the opposite, is it uppercase? Character at. And you put, for example, 1. So here you tell me the position, and then I'll tell you what is the character at that position or index. And I got B. Oh, you see that those methods basically can help you scan the string and look into characters. Well, you know what? I'll just show you how is that possible. By, oh, whoa, why did I go away? What did I just run? No. Okay, here we go. Let's just say for integer I equals 0, and then I is less than str1 dot length, and then I plus plus. And look at this. System out character they are at I. And this basically will give me, again, what is wrong with you? Here it is, length. Copy that, put it here. Do I have to wear my glasses? Length, yes. If you guys are seeing something different, please let me know, because for me, it looks like they're exactly the same. But let's just have a look here real quick. As you can see here, ABC. I did have access. You know what? Let me take the line away and just put a space here. So you'll see the characters printed next to each other.